in your answer using interval notation, whenever you think of domain, always think of all real numbers. That is the initial set of numbers that we're talking about, because when you're finding domain, you want to know what input values can you plug into the function and get an output value. So in most cases, it's all real numbers. Those special cases are fractions because you can't have zero in the denominator of a fraction, and radicals because you can't have a negative under a square root. So in this particular problem, we actually have both scenarios. We have a radical in the numerator, a radical in the denominator, and it's in a fraction. So how do we tackle that? Well, let's address the radicals first. So luckily, these are just pretty simple radicals to look at. So if you look at the numerator, it's x minus 5. So what values can x be? Well, x can be anything greater than 5, because 5 actually creates a 0, and we can't define it as 0. And then everything bigger than that, 6, we do not 1 under the current symbol, 7, 8, under the current symbol, x under the current. And all of those we can take the square root. They may not be perfect fit, but we can take the square root. If we do 4 and go smaller, then that generates negative, and we can't have that underneath the radical sign and have it still be a real number. In the numerator, we have to have x values that are greater than or equal to 5. In the denominator, if you're looking at just the radical, it can be greater than or equal to 4. But we have to be careful with that because 4 goes into 0. We can take the square root of that, so the radical part is fine. However, we would have a 0 in the denominator with that okay. So we can't have x greater than or equal to 4. We actually just can have greater than 4. So the question is, well, how do you write the domain? Well, we have to make sure that when we're talking about domain, it has to apply to both of these. So we need the intersection of these or what they have in common. And that's going to be everything greater than or equal to 5. If it's greater than or equal to 5, it automatically is greater than 4. So our domain is going to be anything greater than or equal to 5. Now, to write that in interval notation, if you visualize your number line, use like do this interval notation. 6, 5, I would use a bracket because I can include it, and I would choose. So what does that look like in interval notation? So bracket 5, comma, infinity, parentheses. And that would be our domain for number 6. Okay, to look at number 7, it says graph the piecewise function. So I'm going to flip over to Desmos, and which is my online grapher, and graph this so we can look at it. So now I'm going to input my functions. I'm going to put both of them in. So I've got x plus 1. So there's that one. And now I'm going to put in my other one, which is negative 2x minus 3. Okay, so I have the blue line is my x plus 1, and the green line is my negative 2x minus 3. So this is just plugging in both functions without putting any restrictions on it. So what I mean by restrictions is you do have that other piece of the piecewise function, and this is why it's called piecewise, because we don't want the entire function or the entire graph, we want a piece of it. And for the x plus 1, I only want when x is less than negative 3. And for negative 2x minus 3, I only want what's greater than or equal to negative 3. So the nice thing is this is a multiple choice problem when you get into your checkpoint or even your review. And so you can already start looking to see which ones meet this criteria. So in looking at my choices, I think I can probably eliminate one of them, but that still leaves 3 of them. So you have to look at just those pieces. So when I'm looking at x plus 1, and I need x values less than -3, if I look on the x-axis at -3, and I go down to my blue line, what I'm looking at is everything below that. And on the other one, I want greater than or -3. So I would still go to -3 on my x-axis, but then I would go to my green line and I want everything greater than. So in Desmos, I actually can put those restrictions on, and so you'll be able to see it. In your graphing calculator, you're not able to do that. So you just want to look at those pieces and really pay attention to x at -3. So let me go ahead and put on those restrictions so you can get a better visual. If you're graphing by hand, what I would recommend is start plugging in x values that begin with -3. And we'll do that here in a minute so you can kind of see what I'm talking about. Okay, now I have put those restrictions on my two lines, so I'm only looking at the pieces that I want to look at. Remember, everything hinges on this x at -3, and so the blue line, I want everything when x is less than -3, so I'm only going to look at that kind of lower left part of the graph. And on my other graph, my -2x minus 3, I want everything where the x or the input value is greater than or equal to -3. So you can see the piece that I'm looking for there. So now I'm able to match it up a little bit better with my four choices. So let's say you weren't sure what this graph looked like. What I would do is generate some ordered pairs for each graph. So if I'm doing the x plus 1, and I need to make sure that everything's less than -3, I would generate my own XY table, and I would start my -x at -3, and I would go less than. So let's just pick a few points. If I plug in -3, that's going to give me -2. If I plug in -4, that's -3. If I plug in -5, that's -4. So I can match these points up to one of my graphs. And I would do the same thing for -2x minus 3. Generate my own XY table. And this time I want greater than or equal to -3, so I would go ahead and start with -3, but then I would go up or go greater. So I would pick these values and plug those in. So if I plug in -3, I'm going to get -2 times -3 is a +6. 6 minus 3 is 3. -2 minus 2 is 4. 4 minus 3 is 1. -1 times -2 is 2. 2 minus 3 is -1. So now I can match up my ordered pairs with my four options that I'm given. On number 8, they give us a graph and it says determine the intervals on which the function is increasing or decreasing. I like this from left to right on my graph. I find this is the easiest way to go, and we're going on the horizontal axis. So looking at my horizontal axis, right, we are going to divide this graph up into pieces, and we're looking for increasing and decreasing. So for increasing, if I start on the left side of my graph, this is decreasing, 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 and then I switch here, and now I'm increasing, 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 and then decreasing again. Okay, so I have one section where I'm increasing and two sections where I'm decreasing. So increasing, divide this out again. Got a lot of colors going on here. So between these two vertical red lines is where my graph is increasing. So I'm increasing from -2 to +1. So my interval is -2, 1, and we're going to use parentheses for that. And they've already got that showing right here. Then where is it decreasing? Well, it's decreasing on the left of -2. So that would be everything from negative infinity up to -2. So that's this right here. And then everything to the right of 1 is where it's decreasing. So that's where they get this interval right here. So there's nothing magical that you have to do to this graph. You just kind of have to pull it apart and look at your x values. Don't look at your y values. Don't look at where the peak is and go, oh, it looks like it's all the way up to 3. No, you're looking at your x values and you're dividing up that horizontal number line and seeing what sections the x's are increasing or the graph is increasing on those x values.